Ah, all right, here we go. Good afternoon, everybody. It's our turn to present, so we are just going to go real briefly over what our climate research study is about. There's four of us, Mr. Ray Bautista, Mr. Mario Duran, Mr. Jerry Loza, and me. And our research project consists of four different areas. Number one, we are doing an atmosphere study, the amount of aerosols in our air on a daily and weekly basis, and on the creation of inversion layers. The second area are the minimum and maximum ground air temperatures. The third one is the pH of our precipitation. And the fourth one is the atmospheric pressure and drought. And we will explain these real quickly on an individual basis. However, before we go any further, we need to remind ourselves that this climate study is for middle schoolers, particularly 7th and 8th graders. We have some 6th, 7th, and 8th graders. Um, our 8th graders will be graduating, in May, so they're going to be mostly on the periphery. It's mostly our 7th and 6th graders and our 7th grade GT students. Hopefully, we'll be able to continue our research for the next couple of years. All right. Before we proceed, let me just give you a little bit rundown as to where we are. As you can see, we are as far west in Texas as you can go. Tyler, where Globe is now, is over here. And realistically, we are about 1,000 miles from El Paso all the way to the eastern border of the state of Texas. So it does cover a broad distance between where we are and where the rest of the state is. If you look at it on a United States basis, you can see that we are right here on the western edge of Texas. The reason why we put this map up here is because our location has a lot to do with our study. If I may just go back one more, I just want to notice that we put Juarez, Mexico here just to show how close we are to each other. In fact, we are a sister city. All we need to do is cross over the border and we are in Mexico. So, the first branch of our study is the amount of aerosols in the air, because we do get a lot of pollution both from the United States and in Mexico, mostly from Mexico because they allow open burning and we don't. In fact, this is getting to be such a problem that El Paso is thinking of preventing wood burning fireplaces now in new homes. And the population of the Metroplex is close to 2 million people. There's about 700 people here in El Paso and about 1.3 to 1.4 million in Juarez. So they do create a lot of pollution. We create a lot of pollution. The subset of our aerosol study is how does this pollution create inversion layers during the winter time, and in turn, how do these inversion layers play on the health of our population, whether they be the younger subset, meaning infants and 3, 4, 5-year-olds, and our elderly population. Real briefly, to show you what an inversion layer is. An inversion layer is created when you have dirty air that built up during the day, where this dirty air is trapped between cooler air on the surface of the earth and cooler air on the higher surfaces of our atmosphere. If you notice, El Paso, back on our map, was at the tail end of the Rocky Mountains. And we are in the middle of a valley created by the Rocky Mountains and the Sierra Madre Mountains of Mexico. So you do have a valley formation, and unfortunately we're caught right in the middle. We have some examples of inversion layers. This one on the upper left-hand corner was a terrible, terrible, terrible inversion layer, and you can see the mountain ranges in the back that don't belong to us. Those mountain ranges belong to Mexico. The lower portion, the lower picture here, shows a pretty well-defined inversion layer with the upper um, air layer being much cooler than on the bottom. And then this picture here was taken 2 Saturdays ago from one of the bedroom windows in my house. I just looked out the window, and again, you can see the Mexican mountains down here, and you can see the terrible inversion layer that was created during the day. What happens? The air is pretty cool during the overnight hours, and then during the day, all this pollution builds up, so that when the temperature starts dropping in the evening, all the cool air comes straight up, and as Mr. Duran just mentioned, it creates a bit of a sandwich. So just to give you a real brief as to what inversion layers do. The principal agriculture products in this area are cotton, pecans, and chili peppers, and we are extending our research into the effects of climate change on our main agricultural products, because there is a noticeable decline in yearly yield, and we're trying to figure out whether climate change plays as important a role in this lower production as we think it does. So, the second branch of our study are maximum minimum ground and air temperatures. Even though we do have a distinct change in temperature during the seasonal changes, it doesn't get cold enough, we don't think, to create a hard freeze under the top layer of soil. You do have some cooling of the ground, but is it hard enough to affect the root systems of our major agricultural products? And if it does create that big a change, that big a variance, how is it really affecting our agriculture? Are our yields diminished because now the ground temperature is getting colder than it was in the past? Our next slide shows the third branch, as that is a pH of our precipitation. There is a difference between the pH in winter precipitation, whenever we get some, and summer precipitation, and we feel that it is due to the inversion layers. All the pollution that gets trapped in the middle of our atmosphere during the winter time has to come down and rain when we get some rain, and in snow. So we're going to be measuring the differences in the pH, and then again relating it to how is this change in pH affecting our agriculture. And then the last arm of our study, this is a little bit more rigorous. Now, keeping in mind that we are gearing our studies to middle schoolers, that is not preventing us from extending our study into areas where our students are not very, very knowledgeable or experienced. Now, we as teachers and adults know that there is some effect going on, but we have to impress it upon our students. They are the ones who are supposed to determine what is going on. The reason why we're talking about the atmospheric pressure and drought, if I may go back to the map a minute ago of the United States. All right, well, here we go. You notice this is El Paso. We are in the middle of our desert belt. The climate and the area itself, the topography of El Paso, is affected by both the Chihuahua Desert and the Sonora Desert. So we are in a pretty dry climate. Most of the moisture we receive either comes from fronts moving to the east, bringing moisture from California, or fronts moving to the west, bringing moisture from the Gulf of Mexico. Now, everybody knows that Texas is going through a severe drought. but we have not experienced a drought as strong as we are experiencing it now. So our question is turning out to be, is climate change forming a barrier so strong that it is not allowing the moisture coming in from the Pacific Ocean to reach us? Not only do we have the problem of the fronts coming in from the west running into the California mountain ranges, which in turn diminishes the amount of moisture we receive. Now we need to worry about, well, are we changing the climate so much that we are not allowing these fronts to reach our area? The same thing is happening to fronts moving in from the Gulf. Are we creating such a strong barrier that the moisture from the Gulf is not reaching us? Now, we do get some snow. We average about 7 inches of precipitation on an annual basis. During the winter, we do get a little bit of snow, but that comes mostly from the dipping of the, what do you call it, the wind stream, the jet stream. So if we get some snow, it mostly comes from Canada or the northern United States moving in with these fronts. So it is a bit of a challenge for our students, but we want to extend it so that we can open up their minds a little bit. The whole climate study that we are doing, all four branches, we are also working in conjunction with Globe affiliated professors at the University of Texas at El Paso, UTEP, and we are getting data from the National Weather Service and whatever other avenues are open to us. So in a nutshell, those are our four branches that we are concentrating on. Um, if I may show you where our weather station is. Mr. Bautista is also our athletic director, and this is his storage shed right here. Um, our weather station right now is right here on this corner, but we are going to need to move it because of vandalism. We are, an open campus. By open, I mean all we have is a small chain link fence that surrounds the whole campus. This fence just shows a tennis court. This is not the height of the fence that encompasses our school. Um, we are an inner city school, and we do have some vandalism. As a matter of fact, they broke into my portable. All four of us are on portables, and they took my webcam and some personal items. Fortunately, we had everything else locked up, and the people who broke into didn't realize what they missed. So we're going to be moving our weather station to a more secure area, but like every other school in the state of Texas, we suffered from the $4 billion budget cuts, and our maintenance budget is low, our security budget is low. We don't have as many security officers patrolling our schools and all. So um, we'll find a way to get it done, but as it stands right now, it is a bit of a struggle. But our kids are very, very enthused. They're starting to realize that, hey, maybe there is something to this climate change. So in a nutshell, that's our study. Any questions, please, by all means, send them forward. Mr. Duran is here. Mr. Bautista had to run out. He said he'd be back in about 15, 20 minutes. So any questions? Here we are.